Welcome back to Tales of Chemistry. Today, we are going to discuss some important multiple choice questions from lesson periodic table standard 10 ICSE chemistry. Question number 1. Which among the following is a better reducing agent? So the first word that I'm underlining, keeping in mind, is reducing agent. Now, under the properties of alkali metals, we have studied that alkali metals are better reducing agents. What is a reducing agent? Well, gain of electron is reduction. So the atom which supplies the electron is a reducing agent, and we know that alkali metals readily lose their electron. They can give away their electron easily. So among the options given here, the only alkali metal is sodium. Name the element having maximum electronegativity. Electronegativity, a very direct question. It is fluorine. Halogens have the maximum electronegativity, and among halogen, fluorine is the one which has the maximum electronegativity. Question number 3. Which among the following is a hydride of an alkali metal? Hydride of an alkali metal. So first of all, you need to look for alkali metals. Lithium is an alkali metal. Magnesium is not an alkali metal. Aluminium also is not an alkali metal. So you have two times lithium repeated, but one is a hydride, the other one is a hydroxide, and the question is, for which among the following is a hydride of an alkali metal? So answer is option A. Question number 4. Identify the covalent hydride from the given examples. Covalent. Sodium is a metal, so this cannot be the answer. Lithium is a metal, cannot be the answer. All of the above definitely cannot be the answer. So the option remains as hydrogen chloride. Is it a hydride? Yes, there is hydrogen. Is HCl having a covalent bond? Definitely yes. So the answer is option A. Choose the most metallic element from the following examples. Now, sodium, potassium, lithium, calcium. Let's figure out whether they come in the same period or group. Okay, so sodium, potassium, lithium. The arrangement could be lithium here, and below lithium is sodium, and here potassium, and calcium is here. Now, so there is down a group as well as across a trend which we need to follow. Down a group, actually metallic character increases. So this has to be the most metallic if you consider down a group. But across a period, metallic character decreases. So the increase is like this. Increase in metallic character is right to left, which means potassium is the most metallic element here. In general, non-metals are dash electronegative than metals. Non-metals are more electronegative. So that was a straight question, more electronegative. The most distinctive property of the noble gas is that they are metallic, no. Metalloid, no. Radioactive, again, no. So the answer is unreactive. Noble gases are unreactive. Across a period, the ionization potential across a period. The ionization potential, meaning the energy energy required to remove the most loosely bound electron, that is the valence electron. So across a period, since the size decreases, it becomes difficult to remove the electron, which means ionization potential should increase. The most electronegative element from the following. Since it is electronegative and most electronegative, we need to look at only non-metals. There are two non-metals, chlorine as well as sulfur. Compared to sulfur, chlorine is the most electronegative element. Which element from the following has the highest ionization potential? Which element has the highest ionization potential? Once again, ionization potential will be maximum for non-metals and noble gas, if any, present. Lithium, boron, neon, carbon. Carbon is a non-metal, but I'm finding a noble gas there, neon, and neon has the maximum ionization potential. It is difficult to remove the electron from any noble gas. Now, which among the following periodic properties are having same unit? So let us write the unit. Ionization energy, unit is electron volt, and electron affinity is also electron volt. Let's look at the other options. Ionization potential EV, electronegativity has no unit. Atomic radius is Angstrom unit. Electronegativity has no unit. Ionization energy EV and atomic radius Angstrom. So the answer is the first one, that is A, ionization energy and electron affinity. If element B is present to the left of element A, so in the periodic table, they appear like that. A will have a smaller size, yes, true. Higher electronegativity. As you move from left to right, electronegativity is increasing. So statement A is correct actually. Smaller size, higher ionization energy. Smaller size, A has a smaller size, true. A has more ionization energy, that is also correct. So I'm finding both A and B correct. Larger size, no, wrong. Look at option D, both the options A and B. So my answer here is, not A, not B, but the answer is B. Identify the element from the following list that has maximum number of electron shells. Number of shells, okay. Calcium has 4 shells because the configuration is 2882. Sodium has 3 shells because of 281. Lithium has 2 shells because of 21. Oxygen has 2 shells, 2, 6. So maximum number of electron shells is for calcium. 14th question. What happens to atomic radius as we move from left to right in a period? So this is just the trend, the direct question. Atomic radius when we move from left to right in a period decreases. Unit of electronegativity. Again a straight question. Electronegativity has no unit. Now, the next one, question number 16. Down the group, electron affinity. Electron affinity is the amount of energy released when an atom is accepting an electron. But down the group, since the size increases, the atom will not be releasing a lot of energy when it absorbs an electron, which means electron affinity decreases down a group. Question number 17. Which among the three, Na, Mg, Al, is most metallic? Metallic character across a period decreases. Down a group increases. Now, sodium, magnesium, and aluminum are across a period. Therefore, sodium will have the maximum metallic character, though the options given makes us feel that aluminum is a perfect metal. Here, just based on the trend in the periodic table, we are calculating the metallic character, and the one which is on the left side is the most metallic one. Which among the following is in the correct order of increasing atomic size? So I can see some non-metals and some metals. Since the increasing order of size is asked, metals will have the largest size. Before that, let's cross-check whether all elements are the same. Yeah, there is Mg in every case, Cl, Na, S in every case. So straight away, I can say the answer cannot be S or Cl because I need a metal at the end. So my options are either B or C. Now let us take B. Sulfur and then chlorine. No, chlorine comes to the right of sulfur, so the size decreases as you go across a period. Now, chlorine, yes, sulfur, magnesium, sodium. Option C happens to be the correct answer because as you go from chlorine to sulfur, you are moving toward the left. So size increases. Sulfur to magnesium, again to the left you are moving, size increases. And finally, sodium. Okay, now question number 19. The atoms of elements, okay, the atoms of elements belonging to the same group of the periodic table have same. Okay, let's read it again. Atoms of elements belonging to the same group of the periodic table. What will they have in common? Number of protons? No. Number of protons vary whether you move across or down a period. Number of electrons also vary. Number of neutrons too vary when you move across a period or down a group. So here the option D is the correct answer. Number of valence electron remain the same. So option D. Which among the following is the correct order of increasing ionization energy? Which among the following is the correct order of increasing ionization energy? Ionization energy increases when the size decreases. So these are all, okay, there is a mixture of down as well as across a period. So whatever it is, let us understand that since it is increasing ionization energy, non-metal should come. So this is not the answer. I'm eliminating option D. Now, out of sulfur and chlorine, we can understand that, chlorine is the one which is having the smallest size. So we are doubting that B could be the answer. But let us evaluate. Potassium and sodium. Yes, compared to sodium, potassium has a larger size. So therefore, it will be, this first two are correct. Yeah, sodium has a smaller size, so its ionization potential will be more. Sodium to sulfur, again size decreases. Sulfur to chlorine, size decreases. So as size decreases, ionization potential will increase. Okay, so that's all in this video. Stay tuned for more questions. Thank you.